Okay, so this last bit, this is page 75, and this is just kind of putting what we've learned so far into practice. We've got 3 points A, B, C. We're given the position vectors of them all. And we've got to work out a bunch of things, including a displacement vector, some magnitudes, a midpoint between B and C, and a position vector that divides it in a bit of a weird ratio, 3 to 7. So if you want to, you can pause the video. I've got the answers up in the corner. Hey, they are. Oh, they are all there. They do fit. So it might be worth drawing it out, having a go yourself, and then coming back to watch my worked solution. Maybe pause the video now and give it a try yourself and come back to it in a moment. All right, here we go. Right, I'm going to draw it out. Let's just get a diagram going here. I'm not going to draw it to scale particularly because the point B is 14 units across. That's quite far, isn't it? It's going to be a bit lazy. So 2i plus 3j, it's roughly here somewhere. I'll put that to scale. B14 minus 2j is going to be roughly here somewhere. It's a bit further across, but it doesn't matter. And C is minus 8i plus 3j. I guess that's going to be back here somewhere. It's not properly to scale. Some element that I have made sure of, though, is I noticed that both A and C had 3j there. Okay. First thing to do is find A, B in terms of I and j. So thinking, how am I going to get from A to B? How far do I need to go across and how far do I need to go up and down? Let's just write the two vectors down. So A is 2, 3, and B is 14 minus 2. And I know that the formula for a displacement vector, I can take one away from the other. So that's my plan. That's what I'm going to do. I'm going to start with B, and then I'm going to subtract A from it. I'm going to do 14 minus 2, take away 2, 3. 14 take away 2 is 12. And minus 2 minus 3 is minus 5. And I'll have a little look. So I have definitely gone to the right, that it's not to scale, and I've gone down. Yeah, that seems quite reasonable. I've gone 5 squares down. That's great. Finding the magnitude. The magnitude formula for any vector is essentially Pythagoras. You take the horizontal and vertical components, you square the individual bits, and you square root it. So the values that I've got for AB are right here, 12 minus 5. So I'm going to sub those into my vector. So into my magnitude formula, 12 squared minus 5 squared. 12 squared is 144. Minus 5 squared, when you square a negative, it becomes positive, 25. And this works out as root 169, which is 13. Cool. You can write magnitude with little bars like this. So if you see sort of straight lines either side of the statement AB, it means the magnitude of, and we've worked out that the magnitude of AB is 13. Nice. Okay, what's next? Find the position vector of M, the midpoint of BC. Okay, I cut the video because I changed my mind on the method. What we're going to do is we're going to look at the formula that uses the lambdas and the mu's that we looked at the last page. So I'll write it down. I'll use the letters B and C instead of A and B. So this was the formula. And if we're trying to find a midpoint, you're trying to find a point that's exactly 1/2 of the way along. As a ratio, that is the ratio 1 to 1. Okay, so there's 1/2 there, there's 1/2 there. So if I substitute in 1 for both mu and lambda, and work this out, I'll see what I get. So I'm going to work out 1b plus 1c over 1 plus 1, and then I can write that as b plus c over 2, really. it's just kind of like a midpoint, really, isn't it? The vector B is 14 minus 2. The vector C is minus 8, 3. I'm going to add those together, and once I've done that, I'm going to divide the result by 2. My face is in the way. So 14 take away 8 is 6. Minus 2 plus 3 is 1. And then I'm going to divide that by 2, and I'm going to get 3, 0.5. There we go, nice. And that's the midpoint of BC. And finally, I'm going to do some position vector stuff, and I'm going to find the point that splits up AC in the ratio 3:7. All right, let's make some space for this. Okay, look at all this space I've got. It's wonderful, isn't it? So I've got my slightly worse diagram now. A and C are roughly plotted, and we're trying to find the point that divides AC in the ratio 3:7. So in other words, if you change that to a fraction, actually, let's just change that quick. There we are. So it works as 3/10. So we're trying to find the point that's 3/10 of the way along the line AC, starting at A and going to C. So the shorter bit of the ratio should be on A's side. The longer bit should be over here. So yeah, the point is roughly here, I guess. This looks shorter than that, doesn't it? What I'm going to do is I'm going to write down my formula once again. I'm going to replace B with C though. So the formula is mu A plus lambda. Instead of B, I'm going to write C. And something to be aware of, I did this wrong just a moment ago. Make sure that you've got lambda on the left. Lambda begins with L, left begins with L. Cool, got that sorted. So lambda is the number on the left, so I'm going to replace all the lambdas with 3's. And I'm going to replace the mu's with 7's. I'm going to see what I get there. So mu is 7, vector A is 2, 3, lambda is 3, the vector C is minus 8, 3, and 3 plus 7, that's going to give me 10. Now let's work this out then. So 7 lots of 2 is 14, 7 lots of 3 is 21. 3 times minus 8 is minus 24, 3 times 3 is 9, and then I'll divide those numbers by 10. 14 plus 24, 14 plus minus 24 is minus 10. 21 plus 9 is 30. Divide both those numbers by 10, and we're going to get minus 1, 3. There we go. So the point that is splitting it in that ratio, 3:7, is minus 1, 3. Cool.